Oh, one final step I missed. Okay, we have taken out the key and we have to put this key back to the array. Then only the code will be complete, isn't it? So what is the position? We have identified the position where we have to insert, and I is decremented once, and we have found that a of I is now less than key. So I have to insert the key in I plus 1th position. So we'll insert a of I plus 1 to be the key. So just because we have written this, okay, we need not say that it is correct. We can work out an example as we did before and say and verify the correctness of the algorithm, but it is not the formal way of doing it. It might work for an example, but it may not be working for some other example. So there should be a way to formally prove that these steps are indeed sorting the input. So for that we are going to use something called loop invariance, which is invariant, okay, which is not changing across loops. Okay, so that is invariance, and we'll use two invariants. The first one is for the for loop. At the start of each iteration of the for loop, the subarray A from 1 to j minus 1 actually has the elements which were originally there in the array, but that will be sorted. That means that with every iteration, if you consider the array elements from 1 to j minus 1, I will have the same set of elements from 1 to j minus 1 which were already there in A, and after the iteration it will be in the sorted order. So we will be using a technique very similar to induction to prove this invariance. The first one is the initialization, which will prove the invariance before starting the loop. So in our case, we start the loop, for loop with j is equal to 2. So when j is equal to 2, j minus 1 will be 1. So a of 1 to 1. So we have just one element, and the one element is actually the element which was originally there in a of 1, and we consider that as the sorted element. That is the initial step that we had. Now the maintenance is to prove that the loop invariance is true before the beginning of an iteration, and it is true before the beginning of the next iteration. To establish that, we need to have the loop invariance of the inner loop, because the body of the for loop mainly has the while loop. So the loop invariance of the while loop is as follows. At the start of each iteration of the while loop, all the elements of the subarray A from I to j are greater than or equal to key. So when we start the while loop, what is I initialized to? I initialized to j minus 1. But is that all that I that we have? Not necessarily, because A of I has to be greater than key before I start executing the while loop. Only if this condition is true, then only I am going to execute the body of the while loop. When we say start of the loop, that means that we begin executing the body of the loop. So although although I is j minus 1, if this A of I is not greater than key, then we are not going to enter the while loop. So the initial value of I is going to be j minus 1. So in our case, j minus 1 is 1. What is j? J is 2. So we are considering the first two elements provided A of I is greater than key. And we know that a of I is greater than key to start with. This is an explicit condition that we have stated in the while loop. And the a of j, which is the second element, is actually the key which we have copied. The key is actually copied as a of j. So it has to be at most equal to the key. So we have satisfied the initial conditions. The maintenance, so inside the while loop, we are moving the element a of I, which is actually greater than the key, to a of I plus 1. And initially a of I plus 1 had an element which is either greater than or at least equal to key. So the maintenance also is ensuring that from I to j, I have the elements which are greater than key, greater than or at least equal to key. So the termination condition is going to give us some useful property of the loop invariance, which is going to help us to prove that we are indeed doing the task in hand, which is sorting. So the while loop, when we keep shifting the elements, we do not lose any data. We are not destroying any data, because when we move, we have copied the element in the rightmost position, which is going to be overridden to key already, and then finally we are going to copy the element key back to array. So we are not going to lose any data, and when we do so, we have the elements in A from 1 to j, which are the elements which were already in the array but now in the sorted array, a sorted order, because of the while loop. So the final termination condition of the loop variance 1 for the for loop is j is equal to n plus 1. Okay, j is actually running from 2 to length of a, and when will j for loop terminates? When j is equal to length of a plus 1. When we say j is equal to 2 to length of a, it is less than or equal to the length, and this is crossing when we go beyond the length, which is, assume if the length is n, when we say when j becomes n plus 1, the condition will fail and we will come out of the for loop. So when we come out of the for loop, or when for loop terminates, j's value is going to be n plus 1. When we substitute this in the loop invariance of for loop, we have a starting from 1 to j minus 1. J is now taking n plus 1. So the minus 1 and plus 1 get cancelled, and we have the elements from a of 1 to n, which were the elements in a originally, and after the complete algorithm, now it is in sorted order. Therefore, we are able to establish that the pseudocode that we have written is indeed doing the sorting. Now let's compute the running time or the time complexity of the algorithm. How efficient is this algorithm? There are many other sorting algorithms. So if we are able to compute the time complexity, it is easier for us to compare against different sorting algorithms and conclude which to choose in a particular scenario. So let's consider a cost of Ci for a statement I. So the for loop is going to the termination condition checking everything we are considering as C1, and how many times this for loop condition is being tested. The loop runs from 2 to n. Say for example, n is the length of a, it is going to run from 2 to n. So we have n minus 1 times, and it will test for n plus 1 and then get terminated. So totally the termination condition would be tested for n times. The next statement, key is equal to a of j, will be executed for n minus 1 times, and let's consider that its cost is C2. Why it is n minus 1 times? Only when the condition is true in statement number 1, then only we get inside the for loop. So if the first statement runs for n times, certainly the second statement, which is inside the for loop, has to run for n minus 1 times. Similarly, the third statement is we assume the cost C3 and it runs for n minus 1 times. Now the while loop, how many times, will assume the cost is C4, but how many times it is actually getting executed, we do not know. It depends on the A of I being compared against key. So we'll assume that for every j it is taking tj times. So for one j it is taking tj times. So from 2 to length of a, which is n, will have the summation running from 2 to n, and we will have tj number of times with every j. Okay, and the statement inside the while loop has to be 1 less than the termination condition of while loop. So we will have summation running from 2 to j, from 2 to n, tj minus 1. Similarly for the sixth statement, assuming the cost C5 and C6. And finally the statement number 7, which is inside the for loop, which is going to run for n minus 1 times with the cost of C7. Now to compute the time complexity, we have to simply multiply the cost with the number of times that particular statement is being executed. So we'll have the equation to be t of n is the running time of the insertion sort. We have simply substituted that. I have multiplied the cost versus the number of times. So we'll have C1 times n plus C2 times n minus 1 plus C3 times n minus 1 plus C4 times summation of tj and so on till t7. Now what is the, so this is kindly an upper, we did not know what is C1, C2, we did not give exact cost and all, we have already approximated them, but we don't actually compute the cost very minutely like this, but we will investigate what is the best case and what is the worst case and finally arrive at the time complexity. The best case will be if the input array is already sorted. If the input array is already sorted, that implies that the while loop is not going to execute at all. That is, the A of I is always going to be less than the key that you are going to take. That means that the while loop statements will not get executed. That means that the cost associated with C5, the number of times the statement number 5 and 6 that will be executed is 0. But the while loop will be, the condition will be tested once and it will fail. So line number 4 will be executed once and line number 5 and 6 will not be executed at all. So you can substitute that and you can find that the terms are linear in nature with n, which is the size of the input.